This lesson is on operations on radicals, and this is to address the competency perform operations on radical expressions. First, let's review simplifying radicals. Example number 1, simplify square root of 25. 25 is a perfect square. Some of the perfect squares are 4, 9, 16, 25, 36, 49, 64, and 81. This 4 is 2 squared. This 9 is 3 squared. This 16 is 4 squared. 25 is 5 squared. 36 is 6 squared. 49 is 7 squared. 64 is 8 squared. And 81 is 9 squared. So the square root of 25 is 5. Example number 2. Simplify square root of 48. 48 is not a perfect square. However, we can factor 48 such that one of the factors is a perfect square. So it's square root of 16 times 3. And the square root of 16 is 4. And 3 is not a perfect square, so it stays under the square root sign. So our answer is 4 square root of 3. Example number 3. Simplify square root of 72 lm squared n cubed. 72 is not a perfect square, but we can factor 72 such that one of the factors is a perfect square. For variables, those that have even exponents are perfect squares. L, the exponent is 1, it's not a perfect square. M squared is a perfect square. N cubed is not a perfect square. However, we can factor n cubed such that one of the factors is a perfect square. Now we are going to factor the radicand. 36 and 2. Then L cannot be factored anymore. M squared is a perfect square. The factors of n cubed are n squared times n. Among these factors, 36, m squared, and n squared are perfect squares. So square root of 36 is 6, square root of m squared is m, square root of n squared is n. So we have 6, m, n. And those that are not perfect squares stay under the square root sign. They are 2, l, and n. So we have our answer, 6mn square root of 2ln. Now let's perform the indicated operation on radicals. Example number 1. If the radicands are the same, we can add the coefficients. So 7, you don't see a coefficient here, it's understood to be 1, so it's 1. So 7 plus 1 is 8. So our answer is 8 square root of 5. We just copy down common radicand. Example number 2. 12 square root of AB minus 3 square root of AB. Now our radicands here are the same, so we can perform the operation on the coefficients. So 12 minus 3 is 9, so our answer is 9 square root of AB. We will just copy down the common radicand. Example number 3. 4 square root of 12 minus square root of 3 plus square root of 27. The radicands are not the same, but we can factor the radicands that will include factors that are perfect squares. These are some of the perfect squares again: 4, 9, 16, 25, 36, 49, 64, and 81. Now we are going to factor 12, so that's 3 times 4. 3 cannot be factored anymore, so it stays the same. Factors of 27, 9 times 3. Now square root of 4 is 2, so we have a 4 outside, so 2 times 4 is 8. So we have 8 square root of 3. We will just copy down this minus square root of 3. Square root of 9 is 3, so it goes out. Then this 3 here is not a perfect square, so it stays inside the square root sign. So we have the same radicands now, square root of 3, square root of 3, square root of 3. So we can perform the operation on the coefficients. So 8 minus 1 plus 3 is 10. Then just copy the common radicand. So we have 10 square root of 3 as our answer. Example number 4. 3 square root of 25ab plus square root of 64ab minus square root of 98a squared b squared. Again, the radicands are not the same, but we are going to simplify the radicals first. So sum of the perfect squares are 4, 9, 16, 25, 36, 49, 64, 81. Now we are going to factor the radicands. So it's 3 square root of 25 times a times b. Then we have square root of 64 times a times b. The factors of 98 a squared b squared are 49 times 2 times a squared times b squared. These are the perfect squares: 25, 64, 49, a squared, and b squared. So square root of 25 is 5, so we have 3 outside. So that means 3 times 5 is 15, so we have 15. A and b are not perfect squares, so they stay inside the square root sign. Square root of 64 is 8. A and b are not perfect squares, they again stay inside the square root sign. Square root of 49 is 7. Square root of a squared is a. Square root of b squared is b, and 2 stays inside the square root sign. So we can add 15 square root of ab plus 8 square root of ab because they have the same radicands. So that's 15 plus 8 is 23. Then we will just copy down minus 7ab square root of 2. So this is our answer. Example number 5. 2 square root of 5 times 8 square root of 7. So we can multiply the radicands if they have the same indices, and we can also multiply the coefficients. So we have 2 times 8 is 16, and then 5 times 7 is 35, so we have 16 square root of 35. Example number 6. 3 square root of 2 times 7 square root of 20. Again, we can multiply the coefficients. 3 times 7, that's 21. And we can also multiply square root of 2 times square root of 20. That is square root of 40. We can still simplify the radicand because we can factor 40 such that one of the factors is a perfect square. The factors of 40 are 4 and 10. So we have 21 square root of 4 times 10. So square root of 4 is 2, and we have 21 outside here. So 2 times 21, that's 42. And then this 10 here, it's not a perfect square, so it stays inside the square root sign. So our answer is 42 square root of 10. Example number 7. 6 square root of 2ab times 3 square root of 3a squared b. Now again, since the indices are the same, we can multiply the radicands, and we can also multiply the coefficients. So 6 times 3 is 18. Then 2ab times 3a squared b equals 6a cubed b squared. Now 6 is not a perfect square. A cube is not a perfect square, but we can factor a cube such that one of the factors is a perfect square, and b squared is already a perfect square. So these are the factors. So we have 18 square root of 6 times a squared times a times b squared. So we have perfect squares here, a squared and b squared. So square root of a squared is a, square root of b squared is b, so we have 18ab outside the square root sign. So we have 6, not a perfect square, a, not a perfect square. These two stay inside the square root sign, so we have square root of 6a. So this is our answer. 18ab times square root of 6a. Example number 8. 21 square root of 20 divided by 3 square root of 2. So since the indices again are the same, we can divide the radicands and also we can divide the coefficients. So 21 divided by 3 is 7, and square root of 20 divided by square root of 2 is square root of 10. So our answer is 7 square root of 10. Example number 9. 4 square root of 150 divided by 24 square root of 3. Since the indices are the same, we can divide the radicands and also we can divide the coefficients. So 4 divided by 24 is 1 over 6, and square root of 150 divided by square root of 3 is square root of 50. Square root of 50 can be simplified. The factors of 50 are 25 times 2. So we have 1 over 6 times square root of 25 times 2. So square root of 25 is 5. So we have a 1 over 6 outside. So that means it becomes 5 over 6 square root of 2. So this is our answer. Example number 10. 30 square root of 7 divided by 2 square root of 3. Now we can divide 30 by 2, but 7 is not divisible by 3. So we can just simplify the coefficients first. So it's 15 square root of 7 over square root of 3. So we can just rationalize the denominator. Meaning to say, we are going to remove the radical from the denominator. And in this case, our denominator is square root of 3. So to remove the radical from the denominator, we are going to multiply our fraction by square root of 3 over square root of 3. So we have 15 times square root of 7 times square root of 3 is 15 square root of 21, and square root of 3 times square root of 3 is just 3. Furthermore, so 15 divided by 3 is 5, so our final answer is 5 square root of 21. Thanks for watching, guys. This is Teacher Rejil. Keep safe.